Continuing in chapter 3, we're going to be talking about applications for systems of equations. Basically now we've developed some techniques for solving systems, and now we're going to see where we can use them in practice. And so there's two main types of problems. I'm going to go through and show you some examples, but there's a variety of different applications where we can use systems of equations. My Math Lab homework and the textbook will have more than just these two types of problems, but they're all very similar. So I'm going to go through and show you an example of an interest problem and a mixture problem. And so the idea behind them and the structure of how you're going to work through these are going to be very similar in each type of problem that you do. I guess the first thing is, with any of these problems, I'm just going to give you a step-by-step kind of how I want you to work them out. And the first thing that you're going to really need to do is focus on setting up your variables. Remember, with a system of equations, you're going to have two equations with two variables, an x and a y, or whatever you want the variables to be. You may change those variables around based upon the problem you have, because you may want the variable to correspond to something specifically, so you might change the letter. For instance, if one of the variables represented time, you might use t for that. And so there's a lot of different ways that you can change those, but I'm going to typically stick with x and y unless it's very obvious I could use something else. So the first thing you really want to do is establish or define your variables. Okay. So you must define your variables first. It's probably the biggest thing that I see students skip over and then get confused somewhere along the problem. If you're very particular and diligent about defining your variables, it's going to help you out later on. So that's the first thing. The second thing that you're going to need to do is to set up a system of equations based upon the wording of a problem. I've got a problem here in the background, which I'm going to go through in a moment, but you're going to use the wording of the problem to set up a system of equations, or to establish two equations with the variables that you just defined. Okay, so you're going to set up a system. Okay. The third thing you're going to do then is just to solve that system. You're either going to use the substitution or the addition method that we learned in a previous section. Okay, so the third step is to solve the system. And then finally, the fourth step, or the fourth part of this that you must really make sure that you include, is a final statement of the solution to the problem. Typically I'm going to ask you to put that in a complete sentence, because I want to see that you really have an understanding of what you just did in the problem, what you were looking for, what you found, and how it all relates. So you're going to state a final conclusion. Okay, so state a final conclusion. So those are the four things I'm really going to be looking for as you work through these story problems. Okay, so let's take a look at this first one. It says Meredith had $1,100 or $1,100 to invest in two accounts. Okay, two savings accounts or some sort of accounts in a bank, or where she's investing this money. One of those accounts is at 8% annual interest and the other is at 10%. So the question then is, how much did she invest in each account if she earned $101 in the first year? Okay, so we know how much she earned, we know how much she invested total, we just don't know how she split it apart. And we also know the rate at which she was earning interest. Okay, so those are some things to keep in mind. Anytime you're looking at a story problem, it's good to read it and reread it and get an idea of what you have, what you're given, and what you need to find. Okay, so I know I'm given that information, the total amount she invested, the rates at which she invested it, and how much she earned in interest. Okay, those are the things I'm given, and I'm trying to find how much she invested in each of the accounts, the details of how she split it up. Okay, now again, I'm going to go back to my 4 steps here. First thing is to define the variables. Well, I always go to the last sentence where it asks the question in order to figure out what the variable should be. It's usually, the variables should pretty much always be the things that are unknown, the things that you're trying to find. And so in this example, it says how much did she invest in each account. And so the variables are going to be the amount at the 8% account and the amount put into the 10% account. Okay, and so I'm going to go ahead and use the variables x and y to represent that, but I need to write it out so it's clear at the end what goes with what. All right, so part 1, or step 1, I'm going to say that x is the amount invested at 8%, and I'll just do this in order of least to greatest, just to keep it straight. And I'll say y is the amount invested at 10%. Okay. Now I'm going to quickly run out of space here, so I'm going to have to erase some stuff as we go. I'm just trying to plan out ahead where everything's going to lay out on the board. The second step then is to somehow set up a system of equations. Now the first thing I know, well, I guess before I do that, I want to get an overall concept. The idea that what you earn in interest is a percentage of what you invest. And so to calculate that, generally speaking, what you earn in interest, the interest I, is equal to what we call the principal, that's the amount you're investing, multiplied by the interest rate. Now we have this thing called a simple interest formula where we also factor in a factor of time, principal times rate times time. But here everything is taking place in a single year, and so the amount of time is 1, so I don't really need to include that. I don't need to multiply by 1 because I multiply by 1 gives you the same thing with or without it, so I'm going to ignore that for now. If this were taking place over a multiple year period, you would want to also multiply by a time factor, t. Okay, so that's my interest formula. Now, in this particular example, I know one thing, the one equation is going to be a little bit easier to construct than the other. In this particular example, I know that the 2 amounts that she invested are going to add up to a total of $1,100. Okay, so she's got $1,100, part of it goes to one account, part of it goes to the other. So those 2 amounts that I'm trying to find, the x and the y, come together as 1,100 if I add them. Okay, so the first equation that I'm going to work with is the one that says x plus y, those are my 2 amounts, must equal $1,100. Okay, so that's the first thing. The second equation deals with the interest itself. I know that Meredith earned a total of $101 in interest. And so the amount she earned in interest from the 8% account is going to be the amount she invested in that account times the 8%, right? So just as a little side note here, the interest from 8% account is going to be found by taking the amount she invested, that's the x, and multiplying it by the percent, which is the 8%. Now if you take x and multiply by 8%, that's really 0.08 times x, right? 0.08 x. And so that's what she earns in the 8% account. Well, then you add to that the amount she earns in the 10% account, which would just be 0.10 times x, or times y, sorry, because y is how much she invested in the 10% account. And so when I take those two amounts, the 0.08x and the 0.10y, and add them together, I should get the total amount that she earned, which is $101. So I'm going to put in here those two things. I'm going to add them together. So the 0.08x is the amount of interest she earned from the 8% account. The 0.10y is the amount that she earned at the 10% account. And those added together should equal the total interest earned of $101. Okay, so this is a system of equations. Now it's a little bit of a messy system because it's got some decimals in there. But we can solve this fairly simple. We can either use the substitution method or the addition method. It really doesn't matter. I'm going to choose the substitution method. With most of these applications, you're going to have some variables that have a coefficient of 1, and they're fairly easy to solve for. You could use the addition method. You'd probably want to multiply this bottom row by 100 to get rid of the decimal, and then try to make the variables work out, or the coefficients work out. But I'm gonna skip that idea and just go to the substitution method. So with the substitution method, I'm going to solve the top equation here for either the x or the y. It doesn't really matter. I'm going to go ahead and use the y for this one. I have a reason in my head thinking forward. I'll show you in a moment. I'll show you in a moment why I chose y. So on this top equation, I'm going to solve for y. Well, to do that, I'm going to subtract an x from both sides. Okay, so this becomes y equals 1100 minus x, which makes sense. The amount at the 10% is equal to 1100 minus the amount at the 8%. Okay, so then I'm using substitution, so I'm going to take that expression and substitute it in to the y in the other equation. And so the other equation then becomes 0.08x plus 0.10 times this new quantity, which will equal 101. Okay, so this new quantity then is the 1100 minus x. Right, so all I've done is I've taken 1100 minus x, substituted it in for y to get this new equation. Now the distributive property here is the step that I want to, that I was trying to be careful on. The reason I chose the y value here rather than the x value to solve for. If I had chosen the x, I'd be distributing a 0.08, whereas solving for y, I'm going to distribute 0.10, which is 10%. It's a little bit easier to calculate 10% than 8%. That's why I chose it. But it doesn't really have to be that way. You could choose either one. So I'm going to go through and distribute. I get 0.08x. 10% of 1100 is 110. So that's, oops, going to be 110. And then 10% of x is a negative 0.10x. Now, you could just do 0.1. I'm doing 0.10 so you can see the 10%, but it doesn't really matter. You could simplify that. And then we get equals 101. I need to go through and finish solving this for x. So I take 0.08 minus 0.10. 800ths minus 1000ths is negative 200, so negative 0.02. You could use a calculator if you didn't see those values right away. So it'd be negative 0.02x plus 110 equals 101. And then, of course, you subtract the 110 from both sides. 101 minus 110 is a negative 9. So I'm left with negative 0.02x equals negative 9. When I multiply both sides by the, divide. I want to divide both sides by the negative 0.02. I'm going to get a final x value. And now this one I might actually use my calculator. Think about that for a second. 200 would be 450 maybe? Let me think. I think it's 450. But if I go 9 divided by 0.02, 450. Yep. And so the double negatives cancel out, so it's positive. And I get 450 for the x value. Now remember, the x corresponds to the amount invested at 8%, so that's $450 invested there. But then we also need the y value, the amount invested at 10%. To do that, I can substitute back in, but I could go back to this green equation here, the y equals 1100 minus x that I wrote in green. I could plug in the 450, and 1100 minus 450 will end up being 650. Okay, so the y value actually, I'll put this in green since I've already written it that way. Y equals 1100 minus the 450, which will give us 650, right? So all that work gets me through step 3, solving the system. The last step then is to state a final conclusion. And I want to do this in a complete sentence so that it's clear exactly what I found and what I was looking for. So I'm going to go ahead and erase some of this initial problem here. And I'm going to state my final answer to say that Meredith invested $450 at 8% and $650 at 10%. Okay? That should give me a final conclusion that very nicely summarizes what the two numbers were that I found, what they mean. So I got units on them, the dollars, and how they're categorized. So that one of them was at 8%, the other one was at 10%, and I'm specific to make sure that that it's clear which one was in each spot. I wouldn't want to flip those around. Okay. All right. So that gives you a pretty good overview using these 4 steps of how to solve an application problem using a system of equations.